thank you for coming here and listening to me talking about typical C++, but why? For those of you who don't know me, I'm Björn Fahller. I work for Net Insight here in Stockholm. I won't bore you with that right now. I do want to talk about this absolutely amazing jigsaw puzzle. I don't know if you knew this. I did not, but it makes sense. Makers of jigsaw puzzles, they have a fixed number of patterns that they make for their jigsaw puzzles. So if you buy 2 jigsaw puzzles from the same maker with different pictures, but they are the same size and the same number of pieces, most probably the pieces are interchangeable. So there is an artist who had made a thing out of this. So he takes different jigsaw puzzles with the matching pieces and creates these amazing interleaved pictures. I absolutely love them. Go to this link you can actually buy these pieces from there. And this one reminds me a lot about the C++ type system. Because, okay, so the reason this reminds me of the C++ type system is that it has a small standard set of jigsaw puzzle piece shapes, which often fit in all the wrong places. I'm specifically thinking about the built-in arithmetic types here that are so convertible to absolutely everything, but also for some of the library types. But C++ allows you to create your own shapes, and you can make them as generic or as specific as you want. It's up to you, because contrary to popular belief, the C++ type system is actually extremely strong, really, really, really strong. It's just completely disastrous with the built-in default types. But everything you build yourself, it's really strong. Now, when we come to C++ developers, most developers create pieces that build up the big picture structure of the program. So you have storage for pending requests somewhere, and you have some buffers for packets there, and whatever, you have those. But you rarely see the information passed between these structures modeled as types. Then you often see the naked ints, for example. And why? Because we can actually use this. And my thought today is that I intend to make you change this in your code by showing a number of examples that have type-based problems and show solutions for how to improve your code. And my aim today is to not do advanced C++. We'll see how well I succeed. But that is my aim. There will be some new things that you may not be familiar with. I'm going to show some C++ 20, for example. But I hope to not do any particularly advanced stuff. So let's get going. I'm going to use a lot of these amazing jigsaw puzzles. First example, wrong argument. So we have code like this. We have something that can read user input, query user data, some way to sanitize the input, maybe escape characters in the strings and such, and then process the result from a query. So we have this function react to user input that reads user input, sanitizes it, and queries the data. So we have the sanitized input, and we log it. But that is not what we actually query. That is a little bit of a problem. We're not querying the sanitized input, so we want to protect against Bobby tables. We really want to do this. And in this case, the authors of this code intended to do that. Otherwise, there wouldn't be a sanitize input function. But they failed to actually make use of the sanitization. They only logged it. And because it is logged, no compiler is going to say anything about this bug. It compiles, it works, there are no warnings here. So what can we do? Well, one thing we can do, we can make a very small change to the function. We can say that sanitize input takes a std string and returns a sanitized string. And our query user data accepts a sanitized string. And we can do this extremely naive implementation. Just a struct that holds a std string as its only member. And if I compile this code, I get this. So now we moved silly programming mistakes from the domain of maybe expensive downtime or very expensive and boring debugging into just, damn, compiler. It failed to compile. I have to fix my program. I prefer this. It's much better. We can do better, though. This struct is maybe a little bit naive. So we can make a class instead, the class sanitized string. And here is something that I don't know how many are familiar with. If you write library code, you definitely know about it. This thing is a conversion operator. So it's an unnamed function that is used to convert one type to another type. So, for example, in this case, we have the function work that takes an int, we have a class C, and we have a function that accepts a C and calls work. And since work accepts an int and C is not an int, the compiler looks, can I make an int out of a C? And it says, yes, we have a conversion operator to int, so I call the conversion operator to int. So you write your conversion operator, the function body does something that returns an int value, and there you have your conversion. This is not quite as type-safe as maybe we would like it. So what we can do instead, since C++ is famous for having all the defaults wrong, the conversion operators are not explicit by default, which they should be, but we can make the code a little bit more verbose and say explicit, because then the compiler will not just accidentally convert a C into an int. We have to be explicit about this in the call to say, hey, give me the int here. So back to our sanitized string. It's implemented in terms of a string. We have it as a value, but it's private. So it's not so easy to accidentally modify this to something that doesn't make sense. And we have the explicit conversion operator, in this case, to a string view. And we have an explicit constructor that may throw if the string just doesn't make sense. Yes?
Is string view part of the newer standard?
String view comes from C++ 17.
Okay.
Yes. Otherwise, it could have returned just a std string or something. Yeah. And by doing this, it suddenly becomes extremely difficult to ever have a sanitized string object that is wrong. And it's extremely difficult to call query user data with something that isn't sanitized. So this code is clean, it's easy to read, and it's very correct. And if you make a mistake, it won't compile. Except, of course, if you have a bug in the constructor to sanitize string that it lets something slip through, but then you have the bug in one place only. You fix that place, and then done everywhere. So just by doing this fairly simple thing of creating a new data type for a sanitized string, we have improved the code. It is more explicit about what we do. It's more expressive. So I think even the extremely simple example with just a struct with a naked member is an improvement. And everybody can do that. That is seriously not advanced C++. But having the private data and a throw-in constructor makes it really easy to do the right thing and very difficult to do the wrong thing. And general advice, almost always use explicit for constructors and conversion operators. Note the word almost. It's not absolutely always, it's almost always. Next example. A load of bool. If you follow me on Twitter, you saw an absolute storm of answers to what to call this problem. But I picked a load of bool. I think it's a good one. You'll see in functions like this. The function takes something and a train wreck of booleans. And then you see the call, in this case in main, false, false, true. Okay, reading the function signature, it makes sense. You can read that. It looks all right. But what the heck is that? Seriously, it's incomprehensible. You cannot read this. And even if you make it readable, some advice is to don't use the constants directly. Use local variables with the name. Don't truncate. It's set to false, and you call it with don't truncate, etc. But you still don't have any guarantees if you happen to call print with these Boolean variables in the wrong order. So it's just a confusing mess. So what can we do? Well, enum class is pretty damned awesome. Because every type, each of these, truncate, pad, and line feed, they are unique types. Don't use C-style enums. They are just glorified ints. Forget those. But the enum class, these are unique types. They are not interchangeable in any way. Each of these holds an off and on value. And we can see the calls here. Call print with foo and truncate off, pad off, line feed on. Now we know what the intent is. It's not just a number of Boolean values. Although I do admit that the names of the actual parameters is, well, it's not pretty. It's not problematic, but it's not pretty, I admit. But I think it's worth the clutter. So you almost never, ever want bool parameters. And you especially don't want plural, several bool parameters. One, maybe, in some situations, but never several. An enum class adds a good kind of verbosity that enhances readability. So for all your flags that you have, use enum class to define them as their own types. It makes life so much easier, even if you have to type a few extra characters, but it's worth it. Then we have one that is sort of kind of related, the dangerous defaults. Now this piece is called the where rabbit. So it's I'm reusing the previous example, except that I'm saying that I want line feed to be default to true, because why don't you want print to do a line, to break the line? It's a sensible default. And time passes. This works. People are happy, even though they shouldn't be, because false, false, true. But it works. But after some time, we realize maybe having this implicit field width doesn't make sense. Maybe we want to say that print within this field and truncate if the string doesn't fit in that, and pad if it doesn't, if it's too short, and then have line feed. This is extremely problematic now, because this change will be expensive debugging for you, because this compiles. Because false is a valid size t.
But you get warnings.
You do not get warnings for this, because the value space of a bool is an unsigned integer that can hold the value 0 and 1. And 0 and 1 fits perfectly fine in size t. You do not lose any precision. Yeah, it's a great language. You can have a lot of fun in C++ for sure. So what can we do? Well, we can actually reuse these enum class types. Now the signature became so unwieldy that I had to break the lines to be able to show it. But this doesn't compile now, because the compiler sees that truncate : off cannot be converted to a size t. So again, we have moved an expensive and unpleasant debugging experience to a compile time error. This actually happened to a few colleagues of mine a few years ago. Not exactly this example, but this problem where they had a default and they had previous parameters that were of types that could be freely exchanged easily. So they added a new parameter before the default, and everything compiled and built, and of course they didn't have sufficiently good unit tests. So they just discovered that sometimes, because this of course only happened in an obscure code path, sometimes weird things happen. This problem is a little bit different compared to the other ones, because what I showed earlier was something that a problem when you write the original code. This is protection against future accidents when you make changes to the code, when the code evolves. You realize that you want to improve something, in this case add a size parameter. So default parameters are extremely dangerous over time if the parameter times before the default are interchangeable. Yes?
Yeah, I was just thinking what you're kind of saying here is that a refactoring should always induce a compile time error if it's not the same.
A refactoring should always induce a compile time error if it's not the same. That is desirable. I don't know if it's always achievable, but it's definitely desirable. Aim for that if you can, and think about that. This is actually a thing that I have noticed with myself over time as experience have grown, is that I start to look at APIs and see, will this evolve gracefully, or is it dangerous? I'm not claiming I always catch all the things, but I am thinking about it. But having unique and non-convertible types do catch this. Then you get compilation errors if you mess up, if you forget one place. So defaults can be dangerous, but they don't have to be if you think about the types you use. Coupled parameters. This is a favorite of mine because I work in networking, and the networking code tends to look like this. So you have various functions that work with, if you have a binary protocol, you have packet buffers that are just contiguous areas of memory, usually identified as a pointer to the start and a length. This is how the POSIX network APIs all look, I think all. So we have this function receive packet where we parse the header, and do something, and then we copy the payload. The payload is all the data behind the header in this message buffer, and we want to copy it somewhere. So we get the buffer pointer to the start, and we say copy the payload from where the buffer begins plus the length of the header. But we got the wrong length. It should be buffer length minus header len. So we have a buffer overrun error. This is great. I think this is a primary source of CVEs. Maybe we actually got one. But can we do something about this? Can we avoid getting into this situation? So the thing is, of course, that the pointer to the beginning, the buffer pointer, and the buffer length, they are expressed as different parameters, but they actually model one thing. They model a view into a contiguous memory area. So let's represent that in one type. So we can do something really simple. A buffer view, a struct with just the naked values as data members, begin and length, sorry. And they are const. Const is very convenient because it means that it's easier to reason about the code, what is happening, because you know that within the scope of a function that has a buffer view, the values of begin and length will not change. And then we have access functions that creates new buffer views. So get the prefix for a certain length, create a new buffer view with the same beginning and the length, and also a suffix after. So give a position and give a new buffer view that represents the tail that comes after the position. How to handle the error cases if the length and position are wrong is, of course, a matter of discussion. I chose, in this case, to truncate. You may abort, you may throw exception, you may have undefined behavior. That's fun. Yes?
Would you think that modern code should use standard range for this instead?
I should use a standard range for this instead. Hang on a few seconds. So then we can rewrite the code like this instead. So say parse header takes a buffer view and returns a buffer view. Copy payload takes a buffer view. Receive packet takes a buffer view. And we say, we get the header from parse header. It gives us a header. And then we copy the payload and say, copy the payload, that the suffix after the length of the header in the packet. I think this code expresses very clearly what the intent of this function is. We're not fiddling with pointer arithmetics and calculating length. We're just saying, copy what comes after the length of the header. This is good. This is a reasonable code to read and understand, yes?
You're encapsulating the playful logic I'm doing directly with the pointers into a named function. So you suggest I shouldn't be going on writing syntax like pointer address plus a length, and I pass that as an argument. You want me to instead have an explicit function named this is what I intend to get out of this function, underscore, and arguments that these two work.
Okay, that was a bit to repeat for the recording, but yes, I am saying do not do pointer arithmetics and calculating length. Do write functions that has a name that tells you what you want instead of having a plus and minus in your code, and that takes the arguments that you need to be able to calculate the next value that you need. However, as great as it is to have const data to work with in terms of being able to reason about code. Immutable members can be extremely problematic. For example, you can probably not put these buffer views in a vector. Depends a little bit on what you want to do with a vector. But many operations on vector want the data type to be assignable. And you cannot assign to a struct with const members. So we can be a little bit more elaborate. Sorry for this wall of code here. Where we have, again, we have start and length as before. They are mutable now, but they are private. And we can have the access functions. I've chosen begin and end because that plays nicely with, for example, the range base 4. So we can just loop over the bytes. And here is a danger lurking, because there is a temptation to add too much here. It's so easy to think, yeah, I want a function that does this and a function that does that, because that is obviously going to be useful for someone in the future. I don't know if you're familiar with John Carmack. He became extremely famous game developer after Doom and Quake. He wrote the game engine for it, and yeah, he's so right. It's hard for less experienced developers to appreciate how rarely architecture for future requirements or applications turns out net positive. Usually you have just written a lot of code that is never used, but it is a maintenance burden for you. So try to avoid that, and write just what you need. And if you find out after some time that actually I needed more, then yeah, go back and add it. You don't have to write the perfect complete type that will never need to be changed ever. You write what you need right now and go back and improve it when you need to.
On the flip side, I've almost never deleted code that might be used in the future, and I deleted it. Never regretted doing that.
Never regretted having deleted functions that weren't used. Yeah, I agree. Same for me. So that is actually a good day at work when if you look at the Git diff for the entire workday and you see that I have reduced the code size by 4,000 lines of code. That is a very good day at work. Yeah. So when you have several parameters that together describe one thing, try to model that thing, whatever it is, as one type. In this case, I had the buffer view. And to go back to your observation earlier, C++20 has stood span, which models a contiguous range of things. So you have a span of t. In this case, it would have been span of uint 8t, or span of const uint 8t, actually. However, do not write your APIs in terms of stood span. Because span is super generic, allows you to do all possible things that you may not that may not make sense at all for a message buffer view. So instead, implement that buffer view in terms of stood span, and then you probably have something else that uses exactly the same span, but used in a different context, and you don't want to confuse those two. And it may have different functions that are exposed. That is my opinion. Others will disagree, including myself a couple of years ago when I wrote a number of functions that used span as the function parameters. Okay, next thing, too many defaults. This is an extremely silly example. I have a class for some server socket. We give it a port, and we have a number of defaults. Do I want this to be a TCP or UDP? Yeah, that is a bit silly, isn't it? String view for the address, it defaults to 0.0.0.0, which is bind to any network address that this host has, but you may want to be precise. In some cases, they say, no, bind to this exactly. And why not be able to support multicast? It defaults to null opt, of course, because maybe you don't, but if you do, you have the ability. And also, do I want it to be blocking IO or non-blocking? This depends. It might be something that is useful. So what happens if I want this? I want actually all the defaults, except that I want it to be blocking. Now I have to. The default parameter values, they are taken in order. We don't have named parameters in C++ function calls. So you have to actually write all of them, repeat their default values just to be able to alter the last one. I don't know about you, but I find that annoying. But what we can do is instead say, yeah, we have a config struct that it holds a port, it holds all the others, TCP or not, the address to listen to, the multicast address, non-blocking, etc. And you give the members the defaults right there and then, which means that if you just create a config struct, it will initialize the variables to these. And then you use C++20, because the designated initializer list for allowing you to name the one parameters, explicitly the parameters that you want to set, or the members that you want to set values to. So I can say, yeah, server socket, port 1666, localhost, and I want it to be blocking. This is a lot easier on the eyes. It's much more convenient. If you don't have access to C++20, you unfortunately have to do this extra step of creating first the configuration and then modify the values, which is not as nice, but it's not terrible either.
Did you compile this code?
At one point I did, but the question was if I compiled it.
I
but
tried to do something like this today, and I got a complaint that I haven't mentioned all the numbers in this temporary struct.
You got a complaint that you did the before C++20 example, or? No. Okay, you did a full C++20, and you got a complaint from the compiler that you didn't mention.
Perhaps the TCP port.
Yeah, that is a good one. I'm getting to that. Specifically the TCP port I'm actually getting to very soon. Because it doesn't have a default value, and this is a creepy one. It's a very creepy one. Because omitting.port is not an error. It is actually extremely well defined what happens when you do this, but it's not an error, but it's almost always wrong. And it depends on which compiler you have if you get a warning. I don't remember. I tried this with GCC, Clang, and MSVC, and it was one of them that I could coerce into complaining. The other two, I failed to get to mention anything at all, which is sad. So you obviously used the right one. But we can use a trick here. This is probably the most advanced code I'm going to show today. The template must init. Must init of T. It has no default constructor. That is the important thing. It has one constructor that takes a value T, and we save it as a member. And we have the conversion operators. Yeah, I just violated the rule I mentioned a little bit earlier, because these are not explicit. And in this case, I think that is perfectly okay, because I want a must init to, for all intents and purposes, be a T, with the exception that I want it to ensure that it is always initialized. So it's all right in this case that the conversion operators aren't explicit. So now we can change our struct to have a must init of uint16t for port. And failure to initialize port is now guaranteed to be a compilation error, regardless of what compiler you have. So that is good. So creating structs with parameters is especially helpful when you have many of them and many of them have reasonable defaults. And it's definitely extra useful in C++20 and later thanks to the designated initializer syntax. So use those. And now we're playing in the wrong key. So I have some kind of broker between client sessions and server sessions, and I have these client IDs that are ints, and I have a map of client sessions and a map of server sessions, and we want to be able to close them. That makes sense. So I close a server with a server ID, and that was maybe not what we intended. What to do? So the problem is this. Client ID and server ID they're just aliases, which for all intents and purposes is a comment saying that, yeah, it's this int, we call it client ID, please only use values that you got from some function that produced client IDs. If you give a file descriptor there, then whatever. Maybe you want to do arithmetics, I don't know, doing calculating the root mean square of all client IDs. Oh. Probably not what you want. So what we can do is, again, go back to the friend enum class. Enum class is amazing. So now I'm saying client ID is an enum class colon int. So I'm saying this is an int, or rather I'm saying this is a type called client ID that is implemented in terms of int. And I have a server ID that is another type called server ID that is also implemented in terms of int. And these are unique types, and they are not interchangeable in any way. So when I have this bug here, I get, again, a compilation error. So instead of a bothersome debugging session, we just get a compilation error, say, fix your code. Your problem is right here. Do something about it. So we can change it and say that we close the server session. And this is good. It's a little bit maybe redundant here, because we have close server of server ID, close client of client ID, and of course you close a server with a server ID, and of course you close a client with a client ID. The thing that you want to close is actually given by the type. Since it's not since it's no longer an alias, it's an actual type, it's an actual real thing. So what we can do is to give the name something that says a little bit more what we wanted to do. We want to close a session. What kind of session? We want to close a server session or a client session. Since these are unique types, we can overload functions on them. We cannot overload functions on type aliases because they are just comments. Sorry? No.
We just call them close.
Yeah, okay, you're arguing about the name, that it should just be called close. Yeah, sure, fine. No complaints from me. I agree. In this case, whether you want to do the overloading these functions or not is a choice. You may want to stay with the old naming. That is okay. But now you actually have a choice. Earlier you didn't. So you have improved your expressiveness of your code. The way this works is that I can create a value x from my client ID by just giving a value of the underlying type, curly brace in it. And to get the underlying type, you use a static cast to the type that is used. And it implements all the comparison operators, so equal, not equal, less than, less equal, greater than, greater equal. So you have them usable directly as, for example, keys in map. So that is fun, that is great. Unfortunately, well, you can argue if it's unfortunate or not, but it's a fact. They do not do, for example, arithmetic operators. If you need those, you have to define those yourself. But you have this, and this is not bad. But what if the keys aren't integer types? What if I want strings?
Can I just ask a question about the code here? Because haven't you really introduced the original problem by renaming these functions? It's very easy to close the wrong kind.
Have I, by using the overload, recreated the original problem that it's easy to close the wrong thing? I don't think so, because you cannot never intend to close a server ID using a client ID. It's a type that carries the information about which you want. It's not the name.
Could imagine that the close method in the client is that the client.close or server.close.
Okay, if I want.
Should work the same.
If I want to have a member function under server ID, client ID, yeah, maybe.
You're saying that in that case you also don't.
In that case, you also don't. Yeah, I understand. It's synonymous in terms of the problem space. Okay, going forward, if we want to use strings as the underlying type, then we have a problem because enum clause only works for integral types. We cannot use them for strings. So what can we do then? Well, we can. You're beginning to see a pattern here, don't you? I have my server ID. It has a private member that is a string value. I have an explicit constructor, and I have an explicit conversion operator. And we really want these to be explicit. But here's the fun thing. C++ 20, the magic starship operator for the comparisons. Writing just this, you need the include compare at the top, and auto operator spaceship const server ID const equal default does exactly what you need. Because now you have comparison of server IDs to each other using the equal, not equal, less than, less equal, etc. of the underlying type, in this case value. And it's even more magic, because if you have several data members, it will do them as lexicographical compares for all the members in the order they are written. This is super cool. If you don't have access to C++ 20, you unfortunately need to write a lot of operators here. So upgrade to C++ 20. Just saying. So enum class is absolutely great for creating new integer types. Like I said, it doesn't do, for example, arithmetic operations, but if you just want values that you can compare, then it's absolutely great. And C++ 20 spaceship operators is amazing. It saves so much work, and it reduces your opportunities to make mistakes. So, to summarize, using types, even fairly simple ones like I showed you now, reduces the risk of calling functions with the wrong values, like the Bobby tables example in the beginning. And it reduces the risk that dependent values diverge, like in the packet buffer view thing. And it makes it easier to manage defaults, both in terms of the dangerous thing where you refactor the code and introduce a bug because the old parameters matched the default, and also in the configuration case where you have a number of things that most of them make sense to just use the default, but occasionally you want to make some changes. And they can help prevent uninitialized data because unfortunately a naked int defaults to what? Well, it depends on the context, but if it's a local variable, it will be whatever happens to be in the memory. And they are much more convenient to write and use after C++20. There is absolutely no denying that. It's super good. It makes your APIs more expressive. Your APIs talk about what you want to do instead of the mechanisms used to get there. And here's the last points are really important. Unless you're very experienced with the problem domain that you're going to use, you don't know beforehand the types you need. Some you may, many you don't. You discover them. As the code evolves, you discover patterns, and you see, hey, this should actually be a type, so I create a type for it. And then you go back to your code, and you do refactoring and use this new type. And when you do that, something absolutely magical happens to your code base. Because I used to think for a very long time that myth about code rot, where you begin with the clear idea of the code architecture and you start coding and everything is beautiful until it hits reality. And it starts to become uglier and uglier and uglier, and you need to address bugs and you come with new requirements, and it just more and more connected in all possible unfortunate ways. And it takes longer to write new functions, it takes longer to fix bugs. But that's a myth. It doesn't have to be that way. When you do go back to do this refactoring, whenever you discover that, hey, I should really use a new type here, introduce that type and introduce it everywhere in your code base. Then your code base starts to evolve into being expressed in the domain of the problem instead of in the domain of the mechanisms to solve the problem. So actually, as time passes, as you work more with it, the code becomes clearer because now the code expresses not what you originally thought it should be, but what it actually is now. So do that. It's well worth the investment in time. That is actually what I wanted to say. If you want to look at more, I really recommend Shandar Dargo's strongly typed containers. Unfortunately, it's not out on YouTube yet. It premieres on September 18th. Watch it when it comes out. It's really good. It's not an advanced talk either, but he looks specifically at making strong types for containers and the traps and pitfalls and the benefits of doing that. And if you want to dive a little bit deeper, Peter Sommerlad had a really interesting presentation at CPPCon last year, the classes we design and how, where he goes into more theory about things to think about when designing types to make the types coherent and unsurprising. And of course, go to this link for the puzzle montage, because these interleaved puzzles are amazing and they are for sale. So go there, just be awed by them, and if you're awed enough, buy one. And that is what I had to say. Thank you.
Considering that enum class is kind of a hack to get strong type integers, do you think that it would be really beneficial to C++ to have like a strongly typed alias for making like containers that span strongly typed?
Given that enum class is kind of a hack, that is useful for integer types, but do I think that it would be beneficial if we had some mechanism in the language for creating safe aliases? Yes, I think that would be very beneficial. And it has been proposed several times, and they have all been shut down for various reasons that I haven't bothered following up. I hope there are technical details, but I don't know. In the back there.
Yes, on slide 31, you showed that, well, you implemented an alias basically for string, but this alias lacks a lot of things that you can do with this string.
Yes. Okay. So the observation is that class ID is now an alias for a string, but it lacks a lot that string has. And that is the point. That is exactly the point. I don't want this to be a generic string that I can do absolutely everything with. I want it to be a server ID that happens to be represented in terms of a string.
Yes, but if you wanted, like, for example, if you wanted to be still acting on a string, could you inherit from a string?
Can I inherit from a string? Yes, and don't. Because it's a very bad idea, because now it's usable everywhere a string is, and that is probably not what you want. You can do here I have the conversion operator to a std string by value. You could have one to a std string reference if you really want to, and say, hey, give me the underlying string and let me manipulate it, please. Or actually in that case, even better, give it a name, give it a function name saying that I really want to ruin this instance here. Yes?
I just want to add that it might seem theoretical, but it actually works quite nice in production. When I inherited quite large code base, it was super messy. It was many, like integer was used for 20 different things. And I started introducing those strong types one by one for different entities, and actually we found and fixed lots of bugs. And there are basically no bugs anymore. So it works, it's real world, and all of these practices we actually do use.
Yeah. Okay, so there was an observation from the back about inheriting an old code base that just use the primitive types everywhere. You know that this is called primitive obsession, by the way. And it was buggy and hard to understand, and he introduced strong types, which clarified the code and helped identify and remove a lot of bugs. I think you were first.
Yeah, well, it was more an observation that I was actually in the mistaken conception that these type aliases were type safe. So it was just an admission of my ignorance there.
Okay, good.
But maybe there are others who have had the
Yeah.
same confusion, or at least
Yeah.
the same question.
Okay, so a member from the audience admitted to having thought that aliases are actually new types. I'm glad you learned something new today. Behind?
Yeah. In the case of multiple booleans, one of the first in the presentation, is it a proposed solution on enum classes with on-offs, but how do you think how it compares to like introducing a bit field for like multiple choices?
How do I feel about using bit fields instead for multiple choices? I think you, in most cases, don't want that, but in some cases, maybe you do. The problem with bit fields, okay.
If it was a
No.
type safe bit.
If it's a struct with bit field members, maybe you can. I'm not sure. I haven't thought about that. The downside of it is, you know that the IQ drops by 20 points when you're on the stage, so I'm not sure. You might be right, but I'm not entirely sure. Mathieu?
Yeah, conversion operators, can they return references? I see a string copy that upsets me.
Mathieu is very upset that he saw a string copy in the conversion operators. Yes, you can return references. Arvid?
I heard the bit field proposal as a flags type.
Yeah.
I
Yep.
think that having type safe flag has a few benefits over using enum classes for rules.
Yeah, okay, so Arvid's observation is that having a type-safe flag fields has advantages. I will have to take your word for it, I don't know right now, but okay.
API for
Yeah.
I will tap and try it later, but I'm asking, what that enum hack, would it work heard from boolean instead of int?
Okay, enum class colon bool. Yes, you can do that. Sure. But then yeah, you can do that. Yeah, but the problem with doing that is, you can do that. I'm not sure you gain so much of it, but yeah, sure. Then you have the flag type curly braces true, flag type curly braces false instead of flag type colon colon on, flag type colon colon off. I think it's a matter of taste. It's okay in both.
Yeah, I changed that for on and off for boolean. I wouldn't do it with that TCD/CDB thing. I use that enough.
Were there more questions, or are we out of time? I think we're running out of time. All right. Thank you very much for your kind attention.